So in this video, we'll look at how we can let the number of rectangles that we use to calculate the area under the curve go to infinity. How can we let n go to infinity? What if we could draw an infinite amount of rectangles? And so those what if questions mean we're going to have a limit. So let's say we have the limit as n goes to infinity. And now we're going to sum up. So we're going to use this summation notation. And I'll start with k equals 1 all the way up to n, where k is just a counter. You can use k, you can use I. And then we will sum up all of those rectangles. So f of c sub k. So that's just an arbitrary point somewhere in the interval times the change in x. Okay, so we're f of c sub k, recall let's just say we have some arbitrary rectangle in here where this distance is f of c sub k. This distance is our change in x. So that's our length times, this is our length, times our width. Okay, because we're taking the limit as n goes to infinity, as the number of rectangles goes to infinity, we can just use some arbitrary point in that interval. Okay, so in order to sum up, in order to evaluate this limit, we're going to have to use something called summation notation. And so there are formulas for that. Well, I'm just going to go over a couple of these formulas. So first of all, let's just say if we have the sum from k equals 1 to n of just a constant, then that will be a constant times n. If we have the sum, and these formulas are in your book and they're on the in-class practice sheet, from k equals 1 to n of k, this is n times n plus 1 divided by 2. Or simplified out, that's n squared plus n divided by 2. And the third one we want to look at, k equals 1 to n of k squared, is going to be n times n plus 1 times 2n plus 1, all over 6. So this works out to be 2n cubed plus 3n squared plus n over 6. I think I have those formulas right. I know this part is right. So what we want to do is we want to take our area, y, under the curve of y is equal to 4 minus x squared in the interval from 0 to 2. And so we'll start off defining what our change in x is. So our change in x will always be b minus a divided by n. In this case, it would be 2 minus 0 divided by n, or 2 over n. And then our c sub k, we're going to start with our left endpoint rather, a, and add change in x times k. And so in this case, that will be 0 plus 2 over n k. And so 2k over n is going to be our c sub k. And then f of c sub k is going to be equal to 4 minus x squared. So I'm just going to replace my x with c sub k. C sub k is 2k over n. We're going to square that. And so this gives me 4 minus 4k squared over n squared. Okay, and now we're going to evaluate that limit. So that limit, as n goes to infinity, this gives me my area. So this gives me my area under the curve, provided that my function is positive, okay? If I have negative function, negative y values, it's not going to calculate. You can't have negative area. So you want to make sure you're up there in quadrant 1, maybe quadrant 2 would be okay, because those are positive y values. And so we have the limit as n goes to infinity of the sum from k equals 1 to n of 4 minus 4k squared over n squared times change in x, so times 2 over n. So before I substitute in those summation formulas, I want to simplify that out. You always want to simplify before you make your next move. Otherwise, these can get really hairy. So this gives me 8 over n minus 8k squared over n cubed. Okay. Now, once we start evaluating the summation, we can eliminate that summation sign. So we'll just be taking the limit as n goes to infinity. 8 over n is a constant, so it's 8 over n times n. That's my constant. And then minus 8 over n cubed times the formula for k squared, which is 2n cubed plus 3n squared plus n over 6. And now we want to simplify this out before we evaluate the limit. Well, let me skip down here because I already have this written out. Okay, so what I did is I replaced my constant with n. This is just a constant. And I replaced my k squared with the formula for k squared. 2n cubed plus 3n squared plus n over 6. And now we want to simplify all of that out here before we evaluate the limit. And so I've just multiplied out 8 times 2 is 16, n cubed over n cubed. So that's going to simplify to just 8/3. And these other two values here, those are going to go to 0. So those values will equal 0 when you're evaluating the limit as n goes to infinity. And so we're left with 8 minus 8/3 is equal to 16/3, or about 5 1/3 units squared, or squared units.